Right, in this video, we're gonna start learning about differentiating. So differentiating polynomials. Polynomials, again, they are the expressions that has x to the power of numbers. So it's like polynomial degree of 2 is quadratic, the polynomial degree of 3 is cubic, and so on and so forth. So this is just a revision from last year. When you're differentiating polynomials, you take away 1 from the power, multiply by the old power. Okay, so when you're differentiating, you always take 1 from the power. So you can notice here, I've got 5. You need to take away 1 from the power. So the new power for the differentiation will be x to the power of 4. And then you multiply the coefficient of the terms by the old power. Same here, you've got 2. 2 times 3 is 6. And then take 1 from the power, give me 2. So that's just a revision from last year. So let's do this. So the coefficient of x to the power of -5 in here is 1. So the answer will be multiplying 1 by -5. And then take 1 from the power, give me -6. So you can see in here. And then the answer is -5 x to the power of -6. The next one here, you've got 3 times -4, so you multiply by the old power, give me -12. You take 1 from the power, give me -5. So that's the final answer. This one here, I've got the coefficients 2 over 3. So I've got -4 times 2, which is -8 over 3 is the new coefficient. And then x to the power of -5. And obviously, because this fraction has you cannot simplify it any further, so you can leave it as it is. So this is all from last year. If you need extra help with this, go back to last year notes, please. Now, sometimes you've got the power or the polynomial term is in the denominator. Before you can differentiate anything, you will have to move the x terms into the numerator first, and then you treat it as the normal polynomial. So you have one more extra step. Now you notice here I've got 7 times, so I've moved it to the negative, so I've moved the denominator up into the numerator. So it becomes, when you're changing places, obviously reciprocal, so you will have x to the power of -3. All this is f to x. I have not differentiated anything yet. Now I will start differentiating, and that's why now I've written f dash to x. So you've again, you've multiplied 7 by -3, and then you take 1 from the power. And then you rewrite your answer as again a positive power, because the question was a positive power. So you just rewrite it in the denominator. So we've got the next questions in here. So again, you've got x to the power of 7 in the denominator. So you move the x to the power of 7 in the numerator. Don't worry about the coefficient. You don't move the 6 up as well. Only the terms that has the variable. So that's why I've got now f to x is written as -5 x to the power of -7 over 6. Next step is differentiating. Okay, so our function now is ready to be differentiated. So we differentiate it as normal, and that's your final answer. All right, now the next. So that's your final answer, 35 over 6 x to the power of 8. Again, you cannot simplify it any further. Now this one here, you've got the fractions. Okay, so I've got this one here is a surds format. So you rewrite it as an index format first. You notice I have not differentiated anything yet. Okay, I'm just preparing my function to be ready for differentiation. So far up to this step is just remember the surds or the roots is mean 1 over 3. It's a fractional. So rewrite it as an index will be 7 over 3. Now I can differentiate. So differentiating is the same, 7 over 3 times 6, and then you can simplify over 6 and 3, and then take 1 from the power, and that give me 4 over 3. So the answer is 14x to the power of 4 over 3. Rewriting it as a surds format, you just, obviously the denominator will be the degree of the root, and then the numerator will be the power for the inside of the roots. This is another one here, so I will prepare it first. So preparing it, rewriting this term into an index format, as we can see in here, 3 over 5, and then just multiplying the power by the numerator, by the coefficient, and then taking 1 from the power. Then simplify the fraction as you can. So this fraction cannot be simplified, that's why. And then you get the answer here, you can see is the power is negative because 3 over 5 minus 1 is a negative answer. So that's why I'll change it into positive first. So moving it to the denominator and then rewriting it as an index format. So now let's do these questions together. So the first thing, remember, we have to prepare the function into differentiating first before we differentiate. So we've got here the surds format. So the first step is rewriting the surds as an index. So that's what so just splitting them, I'm writing it as an index, 7 over 3. Now the power, or the term that has the x in the denominator, we need to move it to the numerator. By moving it to the numerator, becomes a negative power. Now my function is ready to be differentiated. Now I can differentiate negative 7 over 3 times 5 over 4, and then take away 1 from the power. So now it's ready to be differentiated. You've differentiated, simplify, and then rewrite it back. So rewriting it back, the first step, moving the negative into positive, so that's why we move it to the denominator. Now rewriting it as an index format. So it will be the third root because the denominator is 3, so it will be the third root of x to the power of 10. And that's your final answer. Next step, again, our function is not ready yet to be differentiated. So we move the term first, change the term into an index format, so it will be 2 over 5. Now we move it to the numerator, becomes negative x to the power of negative 2 over 5. Now the function is ready to be differentiated. Now we differentiate. You notice I've written fx all the way here. Once you start differentiating, you write f dash to x. You cannot just keep doing equal equal. You must change it to f dash to x to represent that you are differentiating now. Now we multiply by the coefficient by the old power, then take 1 from the power, simplify as we can, and then you got this as an answer. Now we are reversing the process. We're moving the term into a positive power first, then changing it into a surds format. That's your final answer. Now, becoming slightly difficult. So we've got more than one term in here. The first step in this case, you split the fractions. Means you're going to put each one of these numerators over the denominator. Or you can take, because there is no common factor. If there was a common factor in here, you would taking the common factor and simplify, but there is no. So you split the fractions first. And now you're going to change all these fractions, surds format, into index formats. And now you will have to use your power skills. So far we are preparing the function for differentiation. We are not differentiating just yet. So remember when you're dividing, when you're simplifying algebraic terms, you minus the powers. So we're subtracting the powers, so you will have x 3 over 4 minus 1/3 and so on and so forth, and then simplify, we get this. So now our function is ready to be differentiated. So we multiply each term, so the coefficient by this power, the 5 by this power, and then the 1 by that power. So each term separately. So we've differentiated now. Simplify as we can. Now we will write the function or the differentiator result into a positive power first. So we moved it back down to the positive power, then rewriting it as a surds format. So this one will be the roots to the power of, the 12th root, x to the power of 7, third root, x to the power of 4, and that's your final answer. All right, now chain rule. Chain rules means you've got a function, and inside the function there is another function, and so on and so forth. It's like a chain. I always use the Russian doll method. Well, there's no Russian doll method, but it's just, if you remember those Russian dolls, you've got a big doll, and then inside it there is another doll, and then another doll, and so on and so forth. So you differentiate the big doll first, then you come down to the middle doll, the inside doll, and then you differentiate it, then go smaller and smaller and differentiate each dolls until no more dolls there. So for example, here I have 2 dolls in here. The big doll is x to the power of, to the power of 5, the whole bracket to the power of 5. And then the smaller doll is those expressions. Okay, so you've got 3 terms in here. So I'll differentiate the big doll first. The big doll is a polynomial to the power of 5. So differentiating will be 5 times all of that, and then 5 minus 1. You're assuming whatever inside the brackets is just one thing, like an x, y, whatever you want to call it. Just ignore it. You're not going to differentiate inside, okay? Just yet. And once I've differentiated that inside, you notice now I've done this bit here. That's my big doll. I've differentiated my big doll up to the dot. Now multiply by the differentiation of the second doll. Now my second doll is this inside, so I've differentiated, will be 4x minus 3. And that's it. You don't have to simplify any further. Next one here, you can see I've got 2 dolls again. I've got this one here to the power of 2, and I have this bit here, the inside of this bracket. I first need to prepare my function to differentiating the same way that I've dealt with it with the polynomials. So to prepare it with differentiation, you will change it into negative power first. And now I will differentiate the big doll, which is the negative 2. And then differentiate the smaller doll, which is the 3. Okay, so the big doll, negative 2 times that minus 1 from the power times the inside. Okay, and then rewriting as a positive power and simplify as possible. And that's about it. Thank you.